It's still lesson 2, lesson 10-2. We already talked about simplifying radicals, and we've even talked about at the tail end of yesterday, how to rationalize denominators. And we are going to continue rationalizing denominators. What I mean by that is, as of course, it's going to get harder. Okay, so the 3 examples and the problems that you did yesterday all just had a single radical in the denominator, a one-term radical in the denominator, and then you multiplied by that as a fraction and then simplified. So take a look at this example down here. In this one, not only do I have a radical in the denominator, but it is a binomial. The first one has the radical in it, but the plus 3 does not. So I can't just multiply by the square root of 2 because that would cancel this one, but then it would become 3 times the square root of 2, so it wouldn't get rid of it. So we have to actually use more algebra. So over here in the box it says, do you remember that when you FOIL 2 things that are exactly the same with the exception of that sign in the middle, we ended up with 2 middle terms that canceled out because you get one positive and one negative. And what you were left with was the square root of the first and minus the square root of the second. Difference of squares, if you remember going backwards. Okay, so we are going to use that in order to get rid of a radical in a binomial. When we use that, it's a binomial, 2 terms. We are going to use conjugates, and I may or may not have used this term before. I think I did in one of my classes. I talked about it, but not the other. So again, it's the exact same thing, binomial, with the difference being only the middle sign. So if your first number, say, were to have been negative, then in the conjugate it still has to be negative. The only sign that changes is that second one, the middle one. All right? So this, if we look at this one right here, what we're going to end up multiplying by is the conjugate of this denominator. So 2 square root of 3, 2 square root of 2, sorry about that, minus 3. And 2 square root of 2 minus 3. In the numerator, very simple, just distribute the 5. So we get 10 square root of 2 minus 15, because you take 5 times both of those terms. Remember, when you take 5, you take it times the coefficient out front, and then the radical just comes along. But now on the bottom, look at what happens. If I FOIL this out, 2 square root of 2 times 2 square root of 2 becomes 4 square root of 4. And then 2 square root of 2 times negative 3 is negative 6 square root of 2. 3 times 2 square root of 2 is plus 6 square root of 2. And then positive 3 times negative 3 is minus 9. Now, inside right here, this is why we do the conjugates, because you will get 2 terms in the middle that cancel each other out. And they are gone, and those radicals wipe each other out. And that first radical, because we multiplied it by itself, we get a perfect square in the radical. What is the square root of 4? It's 2, and 2 times 4 becomes 8. So we have 8 minus 9, and realistically, it simplifies out nice, negative 1. Now, most people would probably actually divide that out and just get negative 10 square root of 2 plus 15 and get rid of the denominator altogether. That's not going to be the case. A lot of times you will still get a number in the denominator. Okay, so let's try another one. Let's look at the second one. So we got 7 over 3 minus the square root of 7. We are going to multiply by 3 plus the square root of 7 over 3 plus the square root of 7. And let's, in the numerator, I'm going to get 21 plus 7 square root of 7. All right, in the denominator, I'm going to simplify it over here a little bit. 3 times 3 is 9. Then plus 3 square root of 7. Then we distribute this minus square root of 7. So negative 3 square root of 7. And negative times a positive becomes negative square root of 49. These two, as usual, will cancel. And I'm going to get 9 minus 7, because that's the square root of 49. 9 minus 7 is 2. Now, You want to always look at your coefficients to make sure that we can't reduce. 21 doesn't reduce, 7 doesn't reduce over 2, so we are done. Let's try another one. 8 over 3 plus the square root of 3, so 3 minus square root of 3, 3 minus square root of 3, multiply 24 minus 8 square root of 3, all over. And some of you might be able to jump to straight here if you can trust yourself that those middle terms will cancel out. 3 times 3 is 9, and the square root of 3 times the square root of 3 becomes negative square root of 9, which is 3, and 9 minus 3 is 6. Now, this one isn't quite finished, because if you look at the 3 coefficients that we have, we can simplify them. I say that we can divide all 3 of those terms by a 2. And since one is in the numerator, one's in the denominator, we're really just simplifying. So reducing. All right, if I take a 2 out, I have 12 minus 4 square root of 3 over 3. And that is your answer. All right. That's all. That's really it. That's the whole lesson for today. Okay, so we're going to practice using those conjugates and simplifying and getting rid of the radical in our denominators. So your assignment is going to be the back side of your assignment from yesterday. And I think you have right here 37 through 49 all, so only 13 questions. Some of them are very simple, and then they get a little more. You have to use the conjugates down here. And then, of course, the formula, or that one-word problem, make you earn it, right? And then I'm also going to give you this worksheet. So 12, there are 24 and 13, so sorry you have 37 questions to do, but it shouldn't. The lesson didn't take too long, so hopefully you have enough time to get that done. All right. If you have any questions, please come and see me.